will be K medoids clustering. Instead of taking the mean value of an object in a cluster as a reference point, medoids can be used. It is mostly centrally located objects. So let us see an example. Previously we seen about our K means. For that you uses your mean value, whereas here you uses your medoids. Okay, so this will be your algorithm. Initially you supposed to take K random points from your n data points. Also say that with you find out your distance of metric method of any of the method. Next step is to find out your cost. If the cost is decreasing, you will do 2 points. First will be swap M and O associated with the data points to the closest medoid and recompute the cost. If the total cost is more than that, the previous step itself, we will stop it and undo the swap. So let's see an example so that you can understand better. First will be your question is given from 0 to 9. So that is 10 data points is given with x and y. So I am supposed to take randomly 2 medoids. So I choose 3, 4 and 7, 4, which is nothing but 9 and 4th point data point. From that I will calculate my cost by using my Manhattan distance, that is x minus x1 plus x minus x2. So y minus y1 plus y minus y2. Okay, so from 0 to 9, 10 data points x and y is written. For distance for first medoids 3, 4, d, next distance d2 will be 7, 4. So like that I find out my first cluster C1 for d1, which is nothing but 6, whereas g2 for C2 will be 2. So with that I will complete my all my 9 with 9 data points. I will get 6 2 3 7 4 8 6 2 4 0 4 6 5 3 5 1 3 1 0 4, which will be your minimum. Next step will be find out which will be your minimum. That will be formed for your clusters. So எதில் மினிமம் இருக்கோ அதில் போய் கிளக்ஷராக ஃபார்ம் ஆகிருக்கும். ஸோ இது ரெண்டுத்தில் எது மினிமம், 2 will be my minimum. So C2 will be 7 and 6. ஸோ கிளக்ஷர் 2ல தான் 7 and 6ங்கிற டேட்டா பாயிண்ட் இருக்கும். ஸோ லைக் தட் you just fill it. Next step will be to find out your cost of it. So from 1 to 5 and 9 find out my cost of it, and 0 3 6 7 8 4 find out the next cost of it, which is nothing but 20. Now randomly select the non-medoid points and recalculate the cost. So let us see. So randomly I am selecting 7, 3 instead of my 7, 4. So C1 will be 3, 4. Already it's 3, 4 in previous step. So that will be remain the same. Only I will change my one of my data points with this from 7, 4 to 7, 3. So I will recalculate the same way for 0 to 9 with 3, 4 as my D1 and D2 as 7, 3 instead of 7, 4. I will calculate and I will find out my cluster values with that. So C6 and 3 with the which is minimum. So C3 will be 3 will be minimum. So it forms to a cluster 2. So first data point 0 forms to C2. So likewise it will be form your cluster analysis. So I will get C1 as 1 2 9 5 and C2 as 0 3 6 7 8 4. So now I again calculate my cost of value. So 1 2 9 5. So nothing but 1. So which is minimum 3. So this will be 3 plus, so like that I will calculate it. So after that I will calculate my cost, and then my swap cost. Swap cost is nothing but present cost minus previous cost should be greater than 0. So 22 and 20. So first step I got my cost as 20. Remember, so என்கிட்ட ஃபஸ்ட்டு நான் கண்டுபிடிச்ச காஸ்ட் வந்து 20. நெக்ஸ்ட் டைம் நான் கண்டுபிடிக்கிறது 22, which is nothing but the difference is 2, so it is greater than 0. As a swap count cost is not less than the 0, we undo the swap. So hence 3, 4 and 7, 4 are the final medoids. So நம்ம கடைசியாக பார்த்த ஸ்டெப்ஸ் தான் உன்னோட ஃபைனல் ஸ்டெப். Then you draw your graph. So கிராஃபில் ஃபஸ்ட்டு அந்த பாயிண்ட்ஸ் எல்லாத்தையுமே நான் ப்ளாட் பண்ணிட்டேன். ஸோ ப்ளாட் பண்ணிவிட்டு பார்த்தீங்கன்னா ஃபஸ்ட்டு என்னோடய கேல்குலேஷனில் இருந்த மாதிரி, ஸோ which will be that 2, 6. So next will be for C1 3, 8. Next C1 is 4, 7. Next C1 will be 3, 4. So 2, 6, 3, 8, 4, 7, 3, 4. So these all will form one of my clusters. Okay, so these all will be forming my one of my cluster. The same way these all things will form my another cluster. So this is the way to do your clustering. Okay, so the advantage is it will be simple to understand and easy to implement, and K-medoids algorithm is fast and converge in a fixed number of steps. So PAM is less sensitive to your outliers than your partitioning algorithm. So that's all.